Today we're going to talk a little bit about RFID. RFID is actually quite big thing. I'm not sure that we will be able to cover like everything, but we will try at least to cover low frequency RFID. So a little bit about me. I'm Akko, Chief Technical Officer in company Flipper Devices. We develop in flippers. And today I'm going to show you a little bit of how Flipper works with RFID. And yeah, so today's agenda is what is RFID? First of all, when it started, what exactly use it as a transport, and we'll talk a little bit about hardware, what kind of hardware you can find on the market, a little bit of history, and then we're going to talk a little bit about low frequency RFID protocols. So from this point, we are going to abandon high frequency RFID, which also called NFC, and ultra high frequency RFID. But we are going to cover it a little bit in hardware section. Then we're going to talk about reverse engineering of low frequency RFID tags and about Pentest and etc. So let's get started with what is RFID. So the technology itself is based around on top of a couple of really simple things. For example, from the physics that you've learned in your school, you know that there is a transformer, and if you have like two coils, they will be magnetically coupled. And what also was found that if you put some load on your second coil, it also will modulate first coil, and that allows that is backscattering. We call it backscattering. And that means that if, for example, your tag want to send something, it's just enough to short circuit your coil on the second side. So, and it started with really unusual things. There was a spy device called the Thing, which Russians presented to American embassy, and what it was doing is quite ingenious. So basically, the device was fully passive, like no electronics, but it was having an antenna, and it was having some kind of microphone. And the idea is from one point you're providing source of energy, and at another point you are actually getting your signal modulated with this passive device. So the same thing do your RFID tags. They do exactly like that. Then it was 20 more years till the first real application started. And then 10 more years till it became commercially available. And so what we usually have in RFID systems, we have a tag and we have a reader. So they both got some kind of antenna. Reader may have a bigger antenna or smaller. They can be like really tiny or really huge. And there are two main technologies that are currently in use. So one is based on magnetic coupling, and another one is based on electromagnetic coupling. And in the first group, we can find low frequency RFID. It's a 125 kilohertz RFID. Then high frequency RFID, which is also we call near field communication NFC. And then we have two more classes. One becoming like really popular, it's UHF RFID. For example, this one used in retail, like the cost of the tag is literally nearly zero. And it allows like to stick this tag on every single item that you're selling in a store. And then what's even more interesting, those tags actually can be selected one by one, and you can get, if you have, let's say, 100 tags in a basket, you will be able to count them one by one. And there is one more special section for microwave RFID, but this one is not really very well standardized, and we're not going to cover it today. So, use cases for RFID systems. So first of all, it's access control. So one of the most popular cases is access control. Like every office building now got those readers. It's either low frequency RFID or high frequency RFID. In some cases, it also uses it for tracking. For example, you wear a special bracelet and it contains UHF RFID tag, and then it just automatically being read when you go from one section to another. For example, when you're moving in a warehouse, different goods. It's really nice technology to track everything. And then we have our pets, and there is like a international standards of how we're tracking them. And FDAB is actually covering RFID tags for pets. Not only for pets, actually, it's also used for tracking, let's say, samples or different kind of, let's say, you're doing blood tests. In many cases, you will get this RFID tag on the thing where you carry your blood. And then it will be tracked in the system fully digitally. And that removes all those humans' mistakes, which usually happens in that stage. And when we're dealing with health, we probably want it to be as reliable as possible. And then we have payments. The whole big thing about NFC is mostly about payments. It started with EMV, standard which rose from MasterCard and Visa, and now it's becoming bigger and bigger. In Japan, we have a quick pay. In other countries, we have different alternative technologies, which also implement some kind of payment system. Then we have offline. So the special part of the payment systems based on RFID is offline payment systems. So Felica and, for example, some systems that use it in subway, like Troika for Russia, like many different systems in Europe, which uses MiFi. And the whole idea is actually quite nice that you can do transactions immediately. You don't need to keep your system online for any transaction. So assets tracking, equipment tracking, and like possibilities of how you can use RFID is almost limitless. So there are so many different ways of what you can do. So how we classify RFID devices? So first of all tags can be, two main groups is like passive tags and active tags. So what's the difference? The difference is quite simple. Active tags is powered by the battery. They usually have some state. They very often use it in, let's say, trackers that do, for example, record logs of, for example, was your item tilted? Was what kind of, what temperature, what humidity was while it was transported? And that's quite nice. And also active tags, they usually have a little bit longer distance, because if you have passive tags, then you have to provide it enough power. And in order to provide it enough power, you have to create like a very significant magnetic field. So, and that brings us to the second classification type is it short range or long range? So if you're creating access control system that requires like explicitly touch something, you probably don't need like long range sensor. And NFC and low frequency RFID, most of the NFC and low frequency RFID system that designed it for that purpose, they actually short range. But that doesn't mean that you cannot read those tags from longer distance. For example, low frequency RFID tags, you can read it like normal low frequency RFID tag, which was designed for short range systems. You actually can read it, let's say, 4 or 5 meters. There are special antennas that you can buy on AliExpress, or you can create it by yourself. And you need to tune radio a little bit, but that thing will be able to read those tags from a long distance. That also kind of security issue, and we will talk about it a little bit later. So then we differentiate tags by complexity. What exactly this tag can do? So the most simple tags, they're actually quite dumb. They don't have anything. They usually store, let's say, 64 bits of data. And then they just repeatedly transmit this data when they see the field. Then we have a little bit more complex things that may contain additional features like temperature sensor or logging. And then we have like the whole new area where things become really complex. So for example, there are RFID systems which based on EMV and Java card. So what that means, that basically means that you have microcomputer in your card, and you can program almost anything, and it can do really complex things, and you can use all those modern crypto primitives inside of your applications. So that makes things a little bit more secure. But when we will talk about NFC, that will bring us to the topic that legacy systems usually have their own toll, and in some cases this toll makes systems not very secure. Okay, then we have systems which get encryption or don't get encryption. For example, if you're reading, let's say, your pet tag, do you need encryption? Probably no. But there are many access control systems which are based on those legacy old tags which don't have encryption. And that makes things also a little bit more complex. Then we have, if we want to classify the whole system, not only tags, we would like to talk about, is it online system or offline system? For example, if we're talking about online systems, they usually have some kind of server, and they, let's say you're getting some information from your tag, then you're verifying that in database you do really have this tag, and then you do something like opening door. And then before online system became popular, there were the whole set of the tasks where you need offline system. And even now in hotels you can find those card logs, which also uses, they are fully offline, they don't connect to the server. So basically you provision special data on the card, and then your log just reads this data and verifies that, okay, from this day to that day, it should open door. So what else we would like to see? So talking about standards. The whole zoo, because there are so many, so since RFID isn't one technology, isn't one transfer, there are so many variations, there are so many standards. Some of them are made to ISO, and some of them stuck in some niches, and some companies maintain those standards only inside of their ecosystem. So some of them do have documentation, some of them was well reverse engineered, and some of them is kind of security through the obscurity. And we'll talk about it a little bit more. So for low frequency, there are like really three, the most popular one. It's EM Marine, EM 4100. Then we have Indala. Indala, one of the oldest commercially available. I will talk about it. Then we have HID, which is not one standard, which is actually the company that owns huge amount of different technologies, and they cover almost everything from low frequency RFID to high frequency RFID, and even UHF RFID. So for high frequency RFID, so the most of the work is done under the ESA and the NFC forum. They do provide really well written set of standards. Then we have a bunch of regional standards like GIS 6319. This is Felica's transport. Then we have MIFAIR, which is kind of mixture between ESA and NXP's their own system. And for UHF, we actually have only one standard. It's EPC ESA 18000. So EPC stands for electronic data code, something like that. So, and for microwave RFID, we don't have any standards. Like, literally, this thing is just appeared, and everyone who is doing something in this area, they invent their own bicycles. So, now let's talk about hardware. So, low frequency and high frequency, UHF and microwave, and readers. That's what we're going to cover. So for low frequency and high frequency, so as I mentioned, this group is very close to, so those two technologies very close to each other because they are magnetically coupled. So basically it's an air core transformer. And antenna is a coil, and it's very easy to distinguish those tags. If you see like them, or if you see reader, you can see that antenna is actually wired. And that makes analyzing those systems a little bit easier. Then they're usually based on on-off keying, amplitude shift keying modulation. So it means that just your, let's say, oscillation becomes slower or higher. And modulation is quite simple, and you can detect it with really simple hardware. There are some edge cases with Indala, but in general, it's plus minus simple technology that can be easily reverse engineered at home. So, talking about coding, those, despite of the fact that the whole system is based on on-off keying, amplitude shift keying, it got a lot of different variants of how the payload is coded. So phase shift coding, Manchester, NRZ coding, and a couple more. So the general idea is on a physical level, they're trying to like to balance everything. And probably Manchester and Pascal is one of the most popular of used one. Okay, so in the work range for those technologies, it's usually from, like, let's say, a couple of centimeters to 10 meters, something like that, with a special antenna. So how those things looks like? Basically something like that. Like the first thing that you can see here is probably a marine, like one of the simplest tags, and you can see that the coil is actually got a lot of how do you call it? So there are a lot of coils there, and it's easy to distinguish it from NFC antennas. NFC antennas usually got thicker wire, not so many coils, and they're a little bit different. And those things is actually animal ID tags. They're usually made of glass with special coating. So basically, when you're injecting it, this coating prevents the whole thing from moving. So they're plus minus safe, but they still can be broken in some cases, and there are some cases when it was broken inside of the body. It's usually not that bad. They don't place it in they place it in the special areas where it's plus minus safe to extract them if anything go wrong. Then you can see this thing is actually one of those antennas which I was talking about that you can buy on AliExpress. They're really huge, and then they allow you to read tag from like really long distance. So when you would like to want to use it, in real life, if you're a whitehead, probably you're not going to want to use it. But you can put it in your suitcase and just go and collect some cards on your way home. Yep. So there are some problems with NFC and RFID. They allow to read those cards, and if there is no encryption, the system is a kind of vulnerable to this kind of attack. And then more standard chips, more standard coils. So UHF and microwave. So those are also quite easy to distinguish, but in many cases they're first of all, they can be flexible since it's labels. They're a little bit, let's say, they embedded into fabric. You cannot find it. And there was a quite funny story when one of the companies who were producing shoes, they decided to embed those tags inside. And then the whole system, basically it was allowing you to track those persons and those tags got just a static ID. So those tags are usually using traditional antennas. They're very close. They're usually dipoles or some kind of F antennas or some kind of a little bit more exotic structures, since they want it to be readable from any, let's say, distance, any position. They do have a couple tricks on how to achieve that, and we will see it on the next slide. Then usually they're using on-off keying, amplitude shift keying, and not only there are some other types of modulations possible. So when you would like to read it, it will. So designing hardware for those things is a little bit more complex. And when you're designing it, you're usually designing it for one specific tag or one specific type of modulation. They use more complex codings like Miller FM0 pi coding, and that allows them to select specific tag. Basically, that allows them, even if you receive multiple tags simultaneously, it allows you to distinguish information from different tags. So how they look like? Actually, yeah, like that. So in many cases, like in Uniqlo, they're embedded into paper. So basically, you can see them. You can see the content if you will look through the tag and place it on the lamp. Then some of them are like that. So this is traditional dipole antenna. Then some of them is a little bit more complex. Like this one is it's basically dual technologies tag. It supports UHF and it supports probably high frequency RFID. And even more, it got battery and it allows to log temperature. So this is one of those things which they stick on the container when they're sending it somewhere else. And then some of the tags are quite interestingly shaped. So this is one of those things that allows to get as much energy as possible. And also quite easy to distinguish for which type of the tag you're right now looking at. And not only those standard shapes, there are like you can literally pack it in almost anything. So, and as for readers, so a lot of them looks like something really simple. Some of them embedded into the gates. Some of them are like something big and wearable. Some of them like this is designed for pets, and they're quite big because those tags are really small, and in order to get it enough power and read it, you really need a big coil. Yeah, and some tags like UHF tags readers, they can be hidden under the table, and you'll be unable to see it till the whole thing will just magically count your items in the basket. So we're not going to talk about high frequency RFID, UHF RFID. We're going to talk about low frequency RFID. So this is probably one of the most used in do-it-yourself things. So there are like EM Marine is like super popular. So if you're Googling something about Arduino and RFID, you probably will find EM Marine. So we will start with Indala, then we'll go to HEAT, then EM Marine, then FDX. We'll talk a little bit about Wiegand. Despite of the fact that this thing is not really RFID, it got really huge impact on the system that was used back then and the system that use it right now. Then we'll talk about T5577. This is a magic card for low frequency RFID. And just will mention other protocols available on the market. So, Indala, probably one of the first like real applications of RFID in real world. The company was founded in 1985 and probably took biggest part of the market back then. So one of the really nice things that was about Indala is that the protocol was not only designed for online systems, it was also allowing you to design offline systems. So for example, let's say you have a university. Inside of the university you have, let's say, the set of rooms which are quite far from main campus. And you cannot just simply connect it to your main network and get active RFID system there. And that's where this thing becomes handy. Basically, on your card, you can have multiple facilities where the person can go or cannot go. And in the beginning of 90s, Motorola just bought Indala. Yeah, the things went pretty well till the moment when was HID found, and HID also designed a set of technologies which was similar to what Motorola did, which Indala did, and in 2001 he bought this department from Motorola, and now you can find Indala readers that that's sold by HID. So, interesting thing about HID that they bought almost everyone, like literally, like almost every company that was designing some kind of systems and was plus minus popular was bought by them, except Sony and Felica, because it's difficult to buy Sony. Yeah, so once again, Indala we're having online and offline systems, and it was quite unique back then. It was plus minus secure in terms of the key space was big enough. So obviously it was static, but it was big enough. Then security was it was various. So some systems was plus minus secure, some not. And the biggest problem for researchers is that the protocol wasn't documented, like literally zero documentation. And everything you can find right now is either reverse engineering by some of the community guys or just garbage. Anyway, we do support one of the flavors of Indala in Flipper, but yeah, reverse engineering it's pain. Plus, since HID just bought Indala, decided to kill it, it just doesn't make sense. So there are some systems which right now exist in the United States, some systems in Russia, in Europe, but in general, Indala is dead. So HID. Yeah, biggest vendor on the market. They got almost everyone. It's surprising that no one is trying to split them into separate companies because they're really too big. So most of the systems commercially available is either designed by HID or maybe resold by other guys who just marketing it as their own systems. As I mentioned, it acquired almost everyone on the market who was plus minus significant, including Indala. It got whole set, like they cover almost everything, starting with low frequency RFID, ending with UHF RFID. And they also provide like the whole ecosystem of the things, not only for not only like access control systems, but like items tracking, goods tracking. Even as I remember, they do have something for pets. So, and they do have a lot of software for integration. So that makes everything much easier for those who want to build such systems. And since they started to develop those things long time ago, there are multiple protocols, multiple protocol flavors that they use, and some of them, like the oldest one, is actually just a static key, and they are quite simple in terms of how they design it, and they usually have no security. So, and probably most popular. So EM 4100 is actually IC name. It was designed by Switzerland company, and it was like really simple and cheap device, and everyone started to use it for the cards. So like cards with EM Marine was super cheap, and people started to build systems based on it. And since this thing uses like really slow modulations, and it also got 40 beats for the key, which is quite big. And back then it was making the whole thing plus minus safe. Probably even safer than Indala and HID, because products by Indala and HID back then, like for the same price category products, were having 25 beats, 28 beats, which is not very secure, and you can kind of brute force it. So, but YAM 4100, it got no encryption, and somehow it's became really popular in do-it-yourself community. So as I mentioned, if you're searching for RFID and Arduino, you probably will find something that works with YAM Marine. So, and FDX. So at some point, our animals started to travel with us, and we started to thought about how should we make it simple to track animals. And that's where FDX came. So basically, there are two standards, FDX-A, FDX-B, which describes how to track animals. So basically, it describes the content of the tag, which is really simple. It's basically like a country, facility, and then unique identifier. And then you're just placing this unique identifier into your animal passport, and then it simply travels with you, and everyone knows how to read those tags, and those things are quite safe. So also those tags got additional features. For example, some tags got temperature sensor, and you not only can read unique identifier, but you also can read the temperature of your pet. So you don't have to put thermometer into different places, which is kind of nice. And they also use it by humans. I mean, I don't know people who are just getting those tags, and it makes just easy their life easier. So some tags designed to be injected and got some more complex things inside. For example, there are tags that contains MIFAE, MIFAE Classic, and there are tags that contains so basically they contains Java card. So you can write your own software and inject it. And as I remember, some banks, maybe 10 years ago, started to so basically they were providing you, instead of providing you like a physical card, they were providing you chip that you can inject into yourself and then use it as a payment card. So it's a little bit, so the standard itself is quite simple. No security, it wasn't designed to be secure, it was designed to be as simple as possible and as reliable as possible. So, and the Wiegand. Wiegand is something that actually from pre-RFID age. This is technology was used in special cards that got special wires made of special material, and basically you can use it as you can kind of program it, and then you can insert it into a special reader and see and basically read it bit by bit. And those cards was used. You probably can find some mentions in movies where guys coming to work and they putting their like a card like that into a special reader. So it's, you physically have to insert it. So some old series or old movies from beginning of the 90s, they do got this technology. And what this thing brought to us, why is it important for RFID, is that access control systems, online and offline, that was designed back then, they were using Wiegand protocol. And basically it's for each bit, they were having one wire, and one of the variation basically came to our age. And even modern systems, they usually support Wiegand. And Wiegand is dumb as hell. It just sends you payload, let's say 25, 28 bits, 30 bits. And then you can use this payload inside of your system to match this card with some records in your database. And you can find, so basically why it's important for us in terms of security is that since this protocol is not secure at all, it wasn't designed, you basically can disconnect reader, patch into those wires, and hijack payload from any valid card and then replay it. We will talk about it a little bit later. So, and T5577. This is chip by Microchip. This was designed to basically to incorporate any kind of tag. So it's like a tape. Basically, it can record your what do you want to replay, and then it can replay it to your reader. So it's really dumb. It only can be used for static codes, but because it's rewritable and because it can, so basically almost every protocol that we got in low frequency RFID, we can replay with T5577. Like everything. And we do have in Flipper support for T5577 cards. And every protocol, RFID protocol that we support can be replayed. Okay, so those was the most, let's say, most popular things on the market, was most production ready. But there are some there are like a lot of systems available on the market designed by really smaller vendors, and they do have, depending on the country, they do have either small coverage or really huge coverage, and that's what we currently support. But I know that this list is actually much bigger. So if you will find some kind of systems that we don't support, please report to us. So reverse engineering, what can we do? First of all, what tools do we need to do reverse engineering on those systems? So probably like two most popular right now is Proxmark and the Flipper. So the Proxmark is software-defined radio of RFID world. Basically, the hardware was designed in a way when it just captures raw samples, and any new protocol can be added into it. And we are not limited with any specific protocol. So basically, you can design your own with, and you can read, you can write, you can emulate. And as for Flipper, we got some physical limitations, like we do support. If we're talking about RFID, low frequency RFID, and we support all protocols that do repeat the payload. Protocols protocols that do talk between tag and the reader got some limitations. We do support T5577, but some other protocols will be a little bit more difficult to support. Then we have NFC chip by ST that also implements ISA level. So everything that is required for NFC tags and EMV tags, everything is here. MIFE we do support on the read level perfectly. On emulation, there are some limitations that, for example, if your reader got strange frequency or slight frequency offset in your carrier, we may not be able to emulate it. Okay, so let's start with for example, we have a tag. What we can do with it? It's actually quite simple for both for Proxmark and for Flipper. We can use appropriate applications. So, for example, if we don't know is it high frequency or low frequency, what can we do? So the easiest way is just to read it, and if it's reading, it will tell you what exactly it is. Let's say we got some kind of tag that's not supported. And we want to analyze what exactly we have here. So there is a special, in Flipper we have, so exactly the same in Proxmark. In Flipper we have a special menu where we can record raw data. So it's very close to software-defined radio, but not on the early stage, on demodulation stage. So, and when we will get this information, we can do something with it. For example, what we can do with it. First of all, let's get it from SD card. here is our records. So we're recording two different types of modulation: amplitude shift keying and phase shift keying. So it's a little bit different on a physical level, how we're handling them. That's why we need. Then we have the site where we got a bunch of nice things for analyzing what exactly you got. So detecting and capturing stage. So we're trying to read tag. If we get supported tag, then we can go directly to analyzing the data itself. If we have tags that we don't know, we're recording raw data, and then using this raw data, using some other tools to decode this raw data. For example, if we're talking about Flipper, we do have lab flipdev, lab flipnet, where we got a bunch of tools. If not, some of those tools are available directly in Proxmark CLI utility. And so let's take a look on what exactly we just captured. So for example, this tag looks like it's really simple. It got something. It got an RZ coding. You can see that, for example, we have 0 coded with longer duration, and then shorter duration codes 1. So, and we can just put this data into slicer, and slicer will cut the whole thing into payload. And then we can analyze the payload itself, like what exactly we got. Is it repeating or not? Is it waiting something from the reader, or is it just repeating what it got on itself? So after we get this raw dump, we open any tool that can decode it for us. We look for a coding, what kind of coding use it. We then getting bit stream from this, and then we combine those bits into payload. So in some cases, the protocol may have some kind of preamble. In some cases, it's just repeating raw data. It usually takes a little bit of time to figure out what exactly inside. Anyway, those systems are not designed for like huge data transfers, and in most cases, those payloads are really small. Even for EMEV card standard, so basically in most cases they're exchanging with data of 20 bytes the most, 80 bytes the most. And then we can go to the content itself, try to figure out how exactly it's structured. Is it, does it have anything that repeats? Does it get anything, like what is the key space? Can we brute force it? And that brings us to the topic of Pentest, like what exactly we can do to analyze, is this system secure or not? So starting with the card, for example, if we have only the card, what we can do? So most of the cards which, for example, goes from the big vendors, like from, let's say, Felica, they do have identification number, and those numbers are actually quite well structured. So in most cases, in the beginning, you get the chip series, like what exactly, what kind of chip is used, what kind of technologies use it. In some cases, yeah, in some cases you get additional information about modulation and etc. And when we have this information, we can search for the protocol. We can check if it's secure or not, and then we can report it. If we have access, if we don't have access to the card itself, we can, or for example, if we don't have label, we can do the whole thing as I described it before. So basically, we can try to read the samples from the card, then analyze the protocol. If we don't have access to the card, but have access to the reader, what we can do? We can check if it's online or offline. For example, so online systems are quite easy to distinguish from other systems because usually when you touch it with a card, it takes some time. For example, like 600 milliseconds to query this database, get the record, and then open. For example, you guys been in Rakuten, you saw those tourniquets gates on the second floor, and when you're touching, it takes time. That means the system is online, and that means that on your card they don't store any additional information, only identifier that they can use for matching with against the database. So offline systems, they also exist. In some cases, they're quite easily to break. So same thing, you can check labels on the reader. I also have a couple nice tools like this one that allows me, for example, detect if something is trying to read something. For example, you can see that pixel in the background is always trying to query NFC. So, and if you have an NFC card, it will try to respond with it. And the same thing goes with reader. You can just, for example, if I will switch Flipper into reader mode, so you can see this is low frequency. And if I will go to NFC, this is high frequency. So those things are also sold on AliExpress. You can get it for a couple of USD, or you can build it by yourself. So basically, it's just 2 antennas, 2 capacitors, and 2 light emitting diodes. So if we know what kind of reader in front of us, we can try to feed it with some standard tags, feed it with like a default keys. In some cases, it works, especially if it's, let's say, access control system in your apartment building. For some reason, they decide that putting default keys is okay. And in worst case, we can disconnect reader and connect it with and with signal analyzer record the data which we got when we read card. And that will also tell us like what exactly on the inside. And if it's Wiegand, also that makes our work is much simpler. And when we looking at the system itself, so once again, what we want to know, is it online or offline? So online systems usually got some side channel attacks, and if it's offline system, it usually stores everything on the card, and the only thing that you need is just to figure out what bits on the card you need to change to open this thing. Another thing, as I mentioned, is not only about how secure each block in your system, but what kind of link between those blocks. So for example, if you don't use encryption in your internal network, that also can be easily hacked, and Wiegand is one of those examples. This protocol doesn't support encryption. There is literally no encryption, and everything that you catch on the bus can be easily replayed and then use it to open the system. Okay, I guess I don't have time anymore.
Like 3 minutes.
3 minutes, nice, okay. So RFID, it's a huge market. It's not going anywhere. Those systems not going anywhere. Some systems designed to last, let's say, for 10 years, like apartment, like the one that you see in apartment. And that brings us to the topic, are they secure or not? And most of them, not really. What to do with it is another question. So choosing secure system is actually a challenge, and if, for example, you want, for example, you have a new building and you're choosing what exactly to install, please take care about what technology it uses, and ensure that those technologies are really used, not just words, but it's a real hardware that uses it. Security through obscurity is bad. So if someone is selling you a system and saying that we got proprietary super secure protocol, in most cases it will be not that secure. Like the list which I showed at the end of the protocols with those 10 companies. So basically those companies are designing access control systems for apartments. And everything that they designed was easily breakable. We do have some pretty good examples in France, but in general, we do have a lot of problems in this area. Security audit is our responsibility when we choosing those systems, so that's kind of problem. And same goes for new tools, because most of the tools that you got on the market, they either do it yourself, if you're talking about low frequency RFID, or they, like Proxmark, is a little bit expensive and requires like some knowledge. And some tools are not available, like for example for UHF RFID, we don't yet have good tools. So we are currently prototyping new UHF RFID for the flipper, but that takes another couple of years before we will be able to deliver it. And something like that. If anyone got questions, I will gladly answer them.
Unfortunately, we don't have much time for questions. So we will have another presentation in shortly, in a couple of minutes. But thank you, Aku, and thank you for the great presentation. If you have any question, you can actually forward them to our social networks, and we will send them to the speaker and maybe do some Q&A session online later. Yeah, thank you.
Thank you, everyone.